Let's continue talking about a comprehensive review of Calc 2. So our Calc 2 review, this is part 3. The first question is this. It says to set up an arc length function or an arc length integral for y equals the square root of 1 minus x to the 8th from minus a quarter to plus a quarter. So we've got to go from here. Arc length goes from minus a quarter to plus a quarter. It is the square root, the integral of the square root of 1 plus, then I've got to take the derivative of the function, okay? The function is 1/2, the derivative of it, 1/2 times 1 minus x to the 8th to the minus a half times minus 8x to the 7th. So minus 8x to the 7th. So I need to square that. That's the derivative, so that's dy dx. Okay, so we'll put dx here in the integral. 2 into minus 8 gives us minus 4. Minus 4 squared is 16. X to the 7th squared is x to the 14th. And then this is a square root in the denominator, so squaring it just wipes out the square root. So there's our problem. Next one is x is equal to the sine of 6y. And we've got to go from minus pi to y to 0. Same instructions. So the derivative, dy dx, no, dx dy is equal to the cosine of 6y multiplied by 6, chain rule. So the integral is from minus pi to 0, the square root of 1 plus this squared, so 36 cosine squared of 6y, and then dy. So there we go. Next problem asks us to find the integral of the surface area of y equals tangent x from 0 to pi over 4, and we've got to go about x. So it's a surface area problem, so what we do is we have 2 pi, and this is a function of x, so I'm going to have dx out here. I've got 2 pi and then r and then the arc length. Okay, the r value is actually the function, so that's tangent. So tangent x. I don't know if I left myself enough room because then I've got to have the arc length here, or the piece that you normally use in the arc length. So it's the derivative of tangent. The derivative of tangent is secant squared of x. Okay, so we go from 0 to pi over 4. If you want to, you could simplify that a little bit. Actually, this one's easy to calculate because it's got nice answers. You've got tangent and then you've got secant. So tangent x, secant x, dx. Okay, so you could set that up. You could actually do it and find that one out pretty quickly. Tangent secant is the derivative of secant. So anyway, okay, 16. Let's see, number 16. Find the area of the surface. So here's another one with surface area. I've got y equals, and then I'm going to put 7x minus x squared in a square root, and I've got to go from 1/2 to 3/2. So same idea. We've got to go 2 pi. Our function is right here, and so we've got to put that in, 7x minus x squared. Then we've got to put the formula for the surface area, or the arc length, so 1 plus, and I've got to have the derivative of this squared. So the derivative of this, dy dx, over here, is equal to 1/2 7x minus x squared to the minus 1/2 times 7 minus 2x. Chain rule takes effect there. Okay, so square that out. Well, we have got this squared in the numerator, so I'm going to put 7 minus 2x all squared in the numerator. Here I've got 2, got to square that, that's 4. And then this squared is 7x minus x squared. And then we go with dx. And we're going from 1/2 to 3/2. So that is the setup of that one. You could actually go a whole lot further with this one, and I think the problem actually says to do the whole thing. So let's go ahead and do that. If I combine these two square roots, I've got 2 pi. I've got 1/2 to 3/2, and this is all square roots. So inside one square root instead of 2 of them, I've got 1 times this, so I've got 7x minus x squared plus, then I've got 7x minus x squared, and it cancels here. So I've got 7 minus 2x all squared over 4, and then dx. So it actually turns out looking halfway decent. We could go a whole lot further. So square this out. We've got 2 pi. We've got 1/2 to 3/2. 7x minus x squared plus, and then a bunch of stuff over 4. So square that out. I've got what? 49. 2 times 14 is 28. So minus 28x, and then plus 4x squared, and then dx, this is all in a radical. Okay, so that's the whole thing, and actually the 4, the denominator of 4 is also. So if I get a common denominator and put things together, I've got 2 pi. I've got an integral 1/2 to 3/2, and then I've got this square root going. 4 times 7 is 28x minus 4x squared. And then here plus 49 minus 28x plus 4x squared all over 4. Look at this. That drops out. That drops out. So we end up with, forgot the dx, we end up with 2 pi. Integral from 1/2 to 3/2. We've got 49 over 4. Square root of 49 over 4 is 7/2. So I've got to integrate 7/2. So let's see, I can even do that. Okay, so 7 becomes 7x. I've got a pi there, and go from 1/2 to 3/2. So 7 pi times 3/2 minus 1/2, 7 pi. So there's the surface area. Quite a crazy looking problem, but it turns out to be very simple toward the end. Let's keep going. This next question, number 17, says to find the volume of the solid generated by revolving the region in the first quadrant about the x-axis. So we've got to go about x, and it's got a curve y equals sine 4x, so y equals sine 4x, and we've got to go from 0 to pi over 4, so 0 to pi over 4, and let's see, I said that wrong, didn't I? Bounded by x, so bounded by x, and about the line pi equal 4, so about x equal pi over 4. So we've got a sine function that is going to be spun around a vertical line, not about x. So sine tends to, look like this. And this just makes it have a shorter period. So anyway, at pi over 4, you're going to have the sine of 4 pi. So it's going to be right here, 4 pi over 4. So it's going to be at its peak. So there's pi over 4, okay? And we're going to spin it that way. It's bounded here. So we've got to have this spun around that line. Now, your choice to get disks or shells, I vote for disks. The reason I do is because this amount in a shell, or actually that would be a disk, wouldn't it? That amount is just differences of x's, and it would be a dy value. And so if we're going around this way, if we've got dy and this is a difference in x's, that I vote against, actually. I was thinking something else. But I don't want to do that because I don't want to solve this for x. It's going to be arcsine, and that's not impossible, but it's easier to do with shells. So let's do this with shells. Shells will be dx in thickness if I do this. Distance will be from pi over 4 and subtracting x, and the height will be sine x. So let's use shells. So 2 pi, the radius from the axis of revolution out to the function is this number minus the x value. So pi over 4 minus x. So that's the radius. And then what's the height of each one? Well, it goes up to here and it lands down here. So it is sine of 4x. So sine of 4x. And then dx, 0 to pi over 4. So we've got that. Okay. You can do the first part quite simply. The second part is going to be x sine 4x, so that is going to take integration by parts. So what do we have? Well, let's do the first part. We've got 2 pi times pi over 4, okay? 2 pi times pi over 4 is going to be pi squared over 2, so we're going to have pi squared over 2 times the integral of the sine of 4x dx, and that goes from 0 to pi over 4, so that part's easy, relatively. Have to do a little substitution, but not too bad. Then this one is going to be minus 2 pi, and we've got this integral x sine 4x dx from 0 to pi over 4. So this one, u equals 4x, so du equals 4 dx, divide by 4, so we're going to end up with pi squared over 8, okay? Sine of u du, I divided by 4 already, so du, sine u du is minus cosine u, and we're going to go, let's see, if x is 0, then u is 0, so we're going to go from 0 here, and if x is pi over 4, then u is pi. Okay, so that's that part. Cosine of pi is -1, so that makes that +1. So we've got pi squared over 8 times +1 minus, and then the value of cosine of 0 is 1, so minus a minus 1. So this is going to be 2. There we go. So we're going to have pi squared over 4 for that piece. Now that's the simple piece, believe it or not. This one, I'm going to let u equal x, and I'm going to let dv equal sine 4x dx, integration by parts. So du equals dx, and v is equal to, well, I just did this problem, so I know it. It is minus cosine Now I'm going to put the numbers back in, 4x, and then I had it over 4 because of this, so over 4. You can double check that if you want to, but it works. So integration by parts should be uv, all right? So x minus x cosine 4x over 4 uv minus the integral of v du. Here's v minus cosine 4x over 4. Du is dx. I don't have the 2 pi attached, so I'm not doing the whole thing yet. So I've got minus x cosine 4x over 4 plus, and then I've got a 1/4 here. I'm actually going to have another 4 that I divide by, so it's going to be 1/16. Do that by substitution. Okay. Integral of cosine is sine, so sine 4x. Okay. Now, put 2 pi here, got a minus. So, got to go from 0 to pi over 4. And what do we have? We've got minus 2 pi times, okay, cosine of 4 times pi over 4. Cosine of that is cosine of pi, which is minus 1. So we've got minus 1 times minus x, so that is plus x over 4. No, it is not. X is a number, isn't it? It's pi over 4. So this is pi over 4. This is over 4, so it's pi over 16 plus 1 over 16 times the sine of pi, that is 0, minus, okay, 0. Cosine of 0 is 1, and this is 0, so this part's 0. And we've got plus 1/16 sine of 0, so that's 0 also. Okay, whole answer. We have this, we've got pi squared over 4 for the first piece. And we've got all of this, so we've got minus 2 pi over 16. So that is minus pi squared over 8, okay? Minus 2 pi times 0, 0, 0. Okay, so that's gone. So we've got 4 pi squared of, let's see, 2 pi squared over 8 minus 1 pi squared over 8, we get pi squared over 8. So it looks like that should be the final result. So there's the volume of that one. Now, some of these volumes take a lot of work, and that's just kind of the way that is. Let's see, number 18. Number 18 is an integral. It is this. It is find the integral of the natural log of 5x plus 5x squared. So 5x plus 5x squared dx. Now, it's an indefinite integral. You're supposed to use substitution and possibly integration by parts. So I'm going to start with substitution. I'm going to let you, let me use something besides u. I'm going to call it w, okay? So let w equal 5x plus 5x squared. So dw is equal to 5 plus 10x dx, okay? Now, that's kind of a mess because I don't have 5 plus 10x dx here, so I'm kind of stuck, right? So if I take this and I substitute stuff in, here's what I'm going to end up with. I'm going to end up with ln of w, but dx is going to have some x's in it. Dw is going to have some x's in it, and that's not particularly a fine way to go. So we've got to be a little bit more careful. So let's see what else we can do. That's just not a straightforward type question. What I choose to do next is I think I'm going to factor this because ln has a lot of algebra. So natural log, okay? This has a common factor of 5x. So 5x, and then this is going to be 1 plus what? 1 plus x. So I've got 5x, and then I've got 1 plus x. Well, that looks like it might have some options. That using algebra stuff, tells me that that's the natural log of the first one plus the natural log of the second one. And not only that, but this is the natural log of 5 plus the natural log of x, and then plus the natural log of 1 plus x. So, little bit gentler problem that way. Now, I can wipe that stuff out and I can do this. So, I've got to take the integral of the natural log of 5 plus the natural log of x plus the natural log of 1 plus x dx. Okay, natural log does take integration by parts, so let's set that up. Let me do it for this one and see if we can follow through with the pattern. So if we let u equal ln x, then du equals 1 over x dx. If we let dv be the rest of the problem's dx, then v equals x. So uv minus the integral of v du, that's the integration by parts formula, is this. It's ln x times x. So x ln x minus the integral of v, which is here. We've got x times du times 1 over x dx. So this is x ln x minus the integral of 1 dx. So that's minus x. So there's the pattern we have. Okay, that works great for this. Well, if we replace x with 1 plus x, it's going to work for that because the derivative is going to be the same. 1 plus x is not a fancier derivative. So let's use the pattern and go from there. Now, ln 5, that's a constant, so that is just going to be ln 5 multiplied by x. ln x, we just did that one. That one is x ln x minus x. And then this one, if I replace the x's with 1 plus x, I'm going to have this. I'm going to have x plus 1, so plus x plus 1, ln 1 plus x, x plus 1, minus, and then 1 plus x plus c. There are a couple things we can simplify, not much, but there's a little bit, like there's a minus x here, and there's another minus x. There's a minus 1, which could be folded into the plus c, but there's kind of a generic look at that. So integration by parts and some algebra involved. So let's see what else we can do here. Throw my calculator around the room. Might as well. All right, let's see what else. The next problem that I've got is this one. It is listed as number, what do I have here? 19. So number 19, it has the integral of 3x sine x dx. Well, that's got two different kinds of functions. It's got a regular line function, and then it's got a trig function. So I'm going to use integration by parts. It's easy to differentiate this. It's pretty easy to integrate that. So u equals 3x, du equals 3 dx. So that's that part. So the rest of it is dv. So that's sine x dx. V is going to be minus cosine x. So the integral is uv, so minus 3x cosine x minus the integral of v, so minus cosine x, du is times 3 dx. So I've got a double negative, have a 3, so we've got this. We've got minus 3x cosine x plus 3, the integral of the cosine of x dx. So we end up with minus 3x cosine x plus 3 sine x plus c. Integral of cosine is sine. So using integration by parts once again. Let's see here. I'm going to skip number 20 in case you're following, and going to take a look